So now we are going to see the slip. Here also you will have the slip. See, a slip means whenever there are two fields available, definitely there will be some speed difference between them. So that is going to be called as slip. So here you see this F forward rotating. See, this is our reference. With reference, FF is always ahead leading. With reference, FP is always behind lagging. So forward field will rotate in anti-clockwise, backward field will rotate in clockwise, and effectively rotor will be running in anti-clockwise only. And forward field and backward field will be rotating at the same speed, ns. Ns is going to be the synchronous speed, which you already know, and rotor will have a speed of n. So definitely ns and n will not be same. So definitely you will have what is called as your slip. So here you will have two slip, one for forward field and one for backward field. So the forward slip is given by SF equal to ns minus n by ns. So it is going to be your normal slip. It is just like the three-phase slip of the three-phase induction motor, ns minus n by ns. I'm going to denote this as S. Okay. See, when two things are moving in the same direction, only when you subtract, you can find the difference between the fields. So I'm subtracting here. But here you see ns is moving in clockwise, n is moving in anti-clockwise. So when you subtract, effectively it becomes addition. ns plus n by ns. That is going to be the backward field slip. Because of two fields you are having here, forward field and backward field, you will have two slips in both directions. So SF is for the forward field and SB is for the backward field. So SB is going to be ns minus of minus n divided by ns. So if you write this SB in terms of S, I can write it as 2 minus S. If I simplify, I can write it as 2 minus S. Okay, it is going to be 2 minus S. So when the motor stands still means the S is equal to 1. When S is equal to 1 means both the fields will be, SF will also be equal to 1, SB will also be equal to 1. Both the fields will have one slip. But when very slow, when the S value is very, very small, if you find the ratio, it will be close to approximately 1 by 40. So the forward slip will be very, very smaller compared to the backward slip. So SF is 1 by 40 times SB, correct? So SB is going to be larger and SF is going to be smaller at smaller values of slip. Any doubt in the slip here? See, induction motor, we have only one slip because we have only one. We consider all the three phase to be a single component, but here we have two components rotating in different directions. So you have forward slip as well as a backward slip. Is it clear?
Sir, do we
Yes.
need to write small n for this motor, sir, induction motor, sir?
What do we need to?
N is a small n,
Yeah,
not capital
just
N.
just to differentiate from three phase, we are using small ns. The capital ns is for the single three phase, right? To differentiate that, we are using small ns. That's all.
Okay, sir. Thank you.